want to represent 3 cosine theta, that's the red one, and have sketched the blue one as the sine 2 theta. Okay, so on the right hand side is very easy to think about. Okay, see the red, can you see that first of all, like all this black cross here? So that's where your point must be, because that's 0. Okay, this one must stay. Okay, must stay with that point. So it's here. And when adding to 0, that must stay at 0. When I have like, this is 0, so the point will stay here. And same like 0, 0 we have here, and then we have the sine 0, so the point stays cosine. So first of all, that's the point you must label. So those points must be on your graph. Okay, so that's half of the mark gain already. So we have those points. And the next thing is think about, okay, it's easy to sketch a graph when it's both above the x-axis or both below the x-axis. It's very easy to sketch for that. So I will definitely have, oh, where's my the half of the graph? Okay, so something like that. Well, I'm not necessarily sketching for the very exact form, but it will be at the correct place, so that will be fine. So look at the right-hand side. Okay, on the right-hand side of the y-axis. Okay, on the right-hand side of y-axis, I have both, well, in between 0 to pi/2. Both graph is above the x-axis. So the actual graph must be above the both graph as well. So you will be, well, you must have point here and you must have point here. So that's the only shape you can sketch. Okay, go beyond than both graph. And same as the pi/2 to pi period. So that part, both graph below the x-axis, so it will go down. Okay, it will go down there. So it's right-hand side, it definitely looks like this. There's no other way we can sketch for it. And on the left-hand side, okay, on the left-hand side, well, we have 3 points here, and the graph must be in between. Okay, the graph must be in between, and that's how I can sketch for it. There's only one tricky thing we need to think about is, will they have the same, same distance? For example, positive and negative, they have the same distance, then we will have x-intercept. But like looking from the graph, it doesn't look like there's some point like they will have the same distance from the top and from the bottom. And I checked that in the calculator. I solve for 3 cosine x, make equals to the negative of the other one. And the only value I solve out is at the 0 point, negative pi/2 and pi/2, which means there's no other place I have positive and negative have the same value. So therefore, there's no other x-intercept. But that's some information I just know. Like I use calculator to find. I shouldn't use that. So they won't really focus on that and then focus that much on like, do we have another x-intercept? You can just sketch the shape. Okay, you can just sketch the shape. So this is just proof that we don't really have another x-intercept. But like, if we don't have another x-intercept, just from this point, well, to that point, because it's more negative. Okay, it's more negative. And same as the other side, it's more positive because it's the 3 cosine. It's the 3 cosine. So that's the shape we'll have. Not necessary to be a very exact shape, but like when we have all the key points, when the graph is at the right place, that will be fine. Okay, so that's the addition of ordinates for circular functions. Even though it's circular functions, we still use the same idea as before to sketch for it. Let's go up a little bit. Let's not go up first. Let's go to the next page. Okay, I want to determine the rules for the graphs of circular function. Just be careful here. Okay, the most important thing is the amplitude. For the amplitude, okay, A can be negative. That's something you need to be aware of. Okay, we'll talk about the amplitude. A can be a negative number. So you know the amplitude is 2, but your A can be negative 2 as well, because you only take the positive value of the A value, right? Of A, like take the absolute value of A. So it can be negative. Okay, it can be negative. So that's something you need to think about. Okay. And also normally we need to use max or minimum to check answers. Okay, not the middle. Okay, the middle point doesn't help. It must be a maximum or a minimum point to help you to see whether the function is right or wrong. Okay, let's have a look for first one. For the first one, a function with root y equals to a sine blah 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 plus d has a range of that. Okay, range of -2 to 6. So I have y equals to -2 and y equals to 6. Okay, that's what we will have. Y equals to -2 and y equals to 6. So that's the range. My graph is in between that. So something I will definitely know is where's the middle. Okay, the middle I will add this and divide by 2. So that gives you a 2. Add 6 and 9 minus 2 and then divide by 2 is the middle. Like how I can find the middle. Like same as the midpoint. So I know my mean line. Okay, my graph is here. I know my mean line. And I also know the amplitude. Because the amplitude is the distance moved from the midline to top or to bottom. So I will have a 4 as the amplitude. Okay, amplitude is 4. Midline is 2. And also I know the period is 8. Okay, let's write about what we know already. So I will definitely know my d value is a 2. A can be plus or minus 4. Okay, A can be 4, can be minus 4. I don't know yet. Well, like it's possible to be minus 4, but it's also possible to be 4. Depends on the shape of the graph. Next thing is I have a period of 8. Okay, a period of 8. So period is 8 equals to 2 pi over n. So n equals to 2 pi over 8. N equals to pi on 4. So I have worked out the n value as well. So 2 pi over n is the period, and I can find out the n value. Now, like it says what? It says find possible values of a and d and the epsilon. So it's a possible value, so I can assume a is something. Because can you see, I can change this horizontal movement, this like epsilon value here, I can change that to make it satisfied, because the only condition is 2, 2. Okay, I have point 2, 2 on the graph, but I can adjust that value to make it like on the point. So I can assume, like I assume that if a is positive 2, like I can assume negative 2 as well, like I just choose one. So y equals to 2 sine pi over 4 t plus epsilon and then plus the d, which is 2. What I know when t equals to 2, y equals to 2. That's what I know because it's given. So I can find 2 equals to 2 sine. Okay, times that by 2 is pi on 2 plus that plus 2. Okay, what? Yeah. Oh yeah, that's 4. That's 4. Not 2. That's 4. Okay, that's 4. So take is plus 4. Now what I have is 0 equals to sine. Okay, I have 0 equals to that. What's the easiest value you can think for that? What's the, like, sine what is 0? Sine what equals to 0? Sine 0 is 0. And sine pi equals to 0. So what this can be? Can be √2, or it can be minus √2 as well, right? I can make the inside either become a 0 or become a pi, or I can make it 2 pi even. Like, it doesn't matter, but like I'll take, maybe √2 is easy to write, so sine pi equals to 0. So there's a lot of values will satisfy that, and it doesn't really matter what my a value take. If I take -4, it still be the same thing. So that's why it says find the possible values for those things. Okay, so find the possible values. Let's think about this. Okay, this value can be minus √2, can be √2. What else it can be? What's the next value it can be? 0 pi, and I can make it 2 pi, right? 0 pi and 2, 0 pi, 2 pi. 2 pi is 3 pi over 2, right? So what's the pattern you can see here? It's adding what? And pi, right? It's adding pi. Okay, minus √2 adding pi give you √2, and add another pi give you 3 √2. So this value can be, let's say, is just that plus k times pi, where k belongs to z. Okay, same as the general solution. I can add √2 minus √2, 3 √2. I can keep adding pi. Like, that's all the possible values I will take for this. Okay, it satisfies all of these values will satisfy this equation. And also my d can only be 2. My a can be plus -4, because it doesn't matter +4 or -4, you always true, like for the given point, because there's no maximum or minimum point given. So it's very, I can't decide a. And as long as I have a maximum or minimum, I can decide what to say. But if I don't have the maximum or minimum point, I can't work out whether a is positive or negative. So that a is really influenced by where is your max, where is your minimum. So I can't decide that. So it can be possible +4 or -4. And then also I have this value here. This is all the possible values here. And also another one is the n value. Okay, n can be plus or minus as well. You need to understand that. Can be plus or minus as well. Okay, it can be plus minus, because divide by positive n or divide by negative n, it will be the same thing. So it can be plus minus √4 as well. So that's all the possible combinations here. Alright, let's have a look at example 2. Because there's no maximum point given, so it's very hard for me to decide anything. Okay, it's very hard for me to decide anything. All these are possible. All these values are possible. But let's have a look at the next question. The next question is kind of good, because you can see where's the maximum. You have maximum. Okay. I have a half. I have minus a half. Can you tell me what's the coordinates here, please? What's the x coordinates for that? Well, y coordinates must be a half. What's the x coordinates? Okay, so what a half? How we can do it? How? Sorry, what's that? 3. Or the method, I don't need the value. What's the method? Yeah, average this value, okay? The maximum exists in the middle, so we just average those two. So we have that plus that, give me 5 pi on 3, and then we half it, that will be 5 pi on 6. Okay, that will be 5 plus 6. So I actually know the coordinates for that, even though it's not given directly. Okay, even though it's not given directly. What's the amplitude for this question? What's the amplitude for this question? Half or negative half. Like amplitude is half, but A can be positive half or negative half. Okay, A can be positive half and negative or negative half. So let's do this. Okay, so let's write down. Well, A can be plus half or plus or minus a half. Let's assume 1. Let's take positive a half. So y equals to a half sine t plus that. Okay, this is the thing I want to talk about. If you really want to work out something, like you have the graph and you have information for maximum or minimum, you must use those points. You can't use those points. Those pointers are quite useless. It can only tell you some information, but very limited information. Only maximum and minimum point can give you the correct information. Because, okay, I can sketch another graph, reflected graph. You still have the same information. Can you see that? If I reflect the graph, I still have those points. Like those points can be added on this graph or that graph. So it can be on the plus a half, can only minus a half graph. So this cannot tell you any information about whether I should take the plus or whether we should take the minus. So it's quite useless. Do not use the midline point. Use either the max or the minimum. That's why I find the maximum point immediately, like when I see it. Okay, so now I will sub this point in. I will sub the maximum point in. So, okay, let's see the distance. What's the distance between that? Okay, that's a distance of pi. You see that's, and then there's another pi. So 1 period is due to pi. That's why we only have a t. Okay, that distance is a pi. 4 pi minus 0.3 is a pi. And then there must be a pi as well. So it's a full 2 pi period. So that's why you have a single t. There's no coefficient for t. So I sub when t equals to 5 pi over 6, y equals to a half. I'll put that in. Okay, that's what we'll have. Sine what equals to 1? Pi on 2 equals to 1, right? So I will make this equals to pi on 2. So that's a 3 pi on 6. So that is a minus 2 pi on 6. That's a minus pi on 3. So the equation I can write is this. And I can try. Can you see? I can sub pi on 3 in. I have sine 0, and that's a 0. No problem. I can sub 4 pi on 3 in. That gives me pi. Sine pi equals to 0. You have 0. No problem. Well, I have satisfied the maximum point. That's because we use that point to solve. And that will definitely satisfy the minimum point as well. So it is the correct equation. Okay, it is the correct equation. If you take minus to here, okay, it's also possible. But this value cannot be minus pi on 3 anymore. It will be something else. Okay, you need to change that value to satisfy like other things. But it's not only one set of one set of solutions. It can be like a lot of solutions here as well. But the thing is, when you have maximum point, you must use maximum point to find it. Okay, so that's the last page. Let's go up to page 15. It is suggested that the height h meters of the tide above mean sea level on 1st of January is given approximately by the rule that for sign something, t is the number of hours after midnight. Draw the graph y equals to ht over 0 to 24. Okay, well, like it's a quite easy graph. Okay, it's quite easy graph. So I can just sketch the 3 lines because we have mid line at 0, top line at 4, bottom line at 4 as well. I can still use that method. Doesn't matter how easy this question is, I can still use my method. I can make pi on 60, like the angle, equals to pi on 2 to achieve the maximum. So t should equals to 3. T equals to 3 will give me the maximum 3, 4. Okay, so I will have the point here, 3, 4. And then what's the period? The period is 2 pi divided by pi on 6. That gives me 12. So each step will be 12 divided by 4 equals to 3. Okay, equals to 3. So I can count the step. So originally I have here, that's a 3. 3 plus 3, that's a 6. 6 plus 3 is a 9. 9 plus 3 is a 12. And 15, 18, 21, and 24. Okay, that's the domain. So the point can move to the middle, the middle, the minimum, middle again, maximum, middle, midline, and back to the middle. Okay, that's the shape of the graph. Okay, that's the shape of the graph. It's very quick to sketch. You can see that if you're really familiar with this method. You just solve for a maximum point, count for the step size, and then label all the points. Okay, it's a very nice and easy graph. Alright, and let's have a look at, well, I should label 0, 0 here, and that's a 24, 0. Label 1 point, 3, 4, and label that 5, 9, -4. Okay, label some of the key points. So now ask you, when was the high tide? Okay, careful with the word when. When is asking for time. Okay, when is asking for time. So you can see at this point and at this point is the high tide. So I'll say is 3 a.m. and 3 p.m. Okay, 15 hours after midnight is 3 a.m. and 3 p.m. You're asking when, not how many hours after midnight. It's asking about the time. So it's 3 a.m. and 3 p.m. And what was the height of the high tide? Well, that's 4 meters. We know that. It's from the graph. D is asking what was the height of the tide at 8 a.m. So at 8 a.m. is when t equals to 8. So h8 equals to 4 sine pi on 6 times 8. So that is 4 sine 4 pi over 3. Four pi over 3 is here, right? The reference angle is pi on 3, and that's the tangent quadrant. That gives you negative 4 sine pi on 3. So we can see 8 o'clock. 8 o'clock is about here. Okay, you have negative. Okay, you have negative values. So that equals to minus 4 times root 3 over 2, because it's the sine pi on 3, that's root 3 over 2, and that's a negative 2 root 3. Okay, negative 2 root 3. Meters. Okay, meters. Here is the evaluation. Here's the evaluation. Just to evaluate that. Okay. For E, a boat can only cross the harbor bar when the tide is at least 1 meters above mean sea level. When? Okay, it's again asking about when. When could the boat cross the harbor bar on 1st of January? Okay, it's asking about the when. Okay, you can see if I can just sketch 1. Okay, where's 1? 1, 2, 3, 4. That's 1. Okay, when I sketch a horizontal line like this, you can see time here. Okay, I will say time 1, time 2, time 3, and time 4. Okay, so in between time 1 and time 2, the boat can cross the harbor. In between time 3 and time 4, the boat can cross the harbor. So now what I want to find is the time for time 1, 2, 3, 4. Okay, so find that time. So it's what I need to find is the time at those places. So I need to use the calculator to do it, because this is basically 4 sine pi on 6t equals to 1 meters. Okay, a quarter is not a special value, so I can't do that by hand. Okay, so I can say that's 1. Therefore, I'll use calculator to do that. Menu 3-1. 4 sine pi on 6 times x equals to 1, comma x. Not enough, I must restrict the domain. Okay, I must restrict the domain, because for circular function, if I don't restrict the domain, I can't work out anything. It will be general solutions, as I said yesterday. So the domain is 0 to 24. I must restrict it. To restrict the domain, it needs to be outside the bracket. Okay, the bar is outside the bracket. So, and I put the domain in. Yeah, that's the value I have. But obviously, I can't write that. I will go for Control Enter to have the approximate value. Okay, like the rounding values. So I can take more decimals. For example, I take this one. That's not even 1 over yet. Okay, so I times by 16. That's about 29 minutes. Okay, it's about 29 minutes after the midnight. Okay, that's the time 1. So the starting time will be 0029 a.m. Okay, 0029 a.m. That's time 1. 2 where? To time 2 is 5.5. But that's 5 hours and 0.5 something after the midnight. So I will minus the 5 hours first, and I will times this value by 60 to see the minutes. Okay, it's about 31 minutes. So what I can say here is that's 5:31 a.m. Okay, it's 5 hours after the midnight. It's 5 a.m. So it's midnight about 29 minutes after to 5:31 a.m. I can go across the harbor. That's the first period of time. And if you can see the second period of the time, okay, can you see that's the 2 other time? But the decimal places are exactly the same as before. Can you see that? 12.4825 blah 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 and 15.517 something. So the minutes is exactly the same. But hours is 12 hours after and 17 hours after. So what I would say is that's 12:29 p.m. to 5:31 p.m. because it's 17 hours after. It's symmetrical graph, okay? So in the morning I can do that, afternoon I can still do that. So it's exactly the symmetrical points, okay? It's the symmetrical points. So I have 12 p.m. and 5 p.m. Any questions? Okay, no question. That's good. We just rush through circular functions. We have done every single page basically now, but you need to complete everything. Okay, complete everything. Well, we have done the last 3 pages. So what you need to do is before page 14. Okay, complete everything before page 14. Any questions you want to ask? Well, even though we could go really quick, but I have covered everything, so you just need to try to remember what I said. And if you forget, you can go to watch a video. I know it's very quick, so that's why you need to complete the work and to see whether you get it or not. Okay, any questions you can ask me next lesson. Also remember to print the notes. We will start integrations next week. Okay.